Okay, so morning lecturers, my name is Christina. For this time, for this one, I'll be going through a video walkthrough of the question one of our assignment. So, question one will be about word count, and my file given was tragedies. So, for tragedies, I'll need to filter out the occurrence of word and filter them into two different text files, one being word count less than 2 and one being word count more than 5 equals or less than 10. So before we start, because there's a need to establish a HDFS connection, so let's check the sandbox file Hottenbox 2.2. So now we know that the IP address is 192.168.56.1.3. So yes, let's start. So I'll just let it run here while I go through the components. So what happened was I have a P message box that will come up like welcome to word count and ask us to input our class. Let's just put an example, just TO4, this is just an example. So when it starts to build the job, and then let's just give it a moment. Okay, so like now you can see that the job is getting completed. So it will come out as a welcome to account and TO4, which is what we input just now. Okay. Okay. So what happened was over here I established a connection to HDFS 2.2 where I uploaded the file tragedies. So here 2.2 and word count tragedies was here. And then followed by T Java role where I actually replaced all the special characters. These are the code for special characters. And then everything to lowercase. I replace all special characters with blank space and then everything to lowercase. So there's a documentation here. It converts a small cap for easy countings. And then using a T normalize, I removed all the commas. Calculate is used to calculate the amount of word counts. So before that, we go through the schema. So the schema for here is line. Line is the lines of the words in tragedies. And then of course the schema here will be line as well because that's the only schema we have now. And then for T normalize, schema will still be line where we separate away all the commas. So for the calculate part, just give me a moment. Alright, so for the calculate part, we input the column word. Schema here we added word over here, as in word and word count. So the word our input column position was line, so the line means words in this case, and then our output column, which is what we added with the word count, is using the function count, we count by the line. And then after that, I just replicate the file with the results with the schema as of here. And then into two different rows, filter rows, one is lower or equals to 2 and another one is greater than 5 and lower or equals to 10. Both using the same schema here. Okay, so what happened was they were both loaded to text files and stored at this output with the field separator of a delimiter. The schema will be word and word count. So let's just check if it comes out. Yes, this is lower or equals to 2 and here is the more than 5 and less or equals to 10. So I finished my video walkthrough for question 1. Thank you for listening. Morning lecturers, my name is Christina. Now I'll be going through a video walkthrough of my question 2. So question 2 is about filtering out incorrect spelling and correct spelling by the assigned dataset. So the dataset I'm assigned with was Premium Bus Service 1. It is a CSV file, and what I do with this is that I created metadata for the Premium Bus Service 1 CSV file over here. As you can see, I input the purpose, description, and as well as the format to Windows. Escape chart setting is CSV, of course. The field separator is comma, and header the number 1. So as we can see from the preview here, we have all our columns. And of course, you take a look at the metadata schema. The schema will be used, and I also downloaded the actual data set online to do a fuzzy match, so we could filter out what's the correct and what's the wrong data. So similar to the Premium Bus Service 1 that I was assigned with, I created a metadata for it. So using T fuzzy match, I actually looked up to the correct data. As you can see, row 2, row 2, and row 2. Yes, here. The origin data destination text, because this is where the spelling errors are found, and matching up with the column origin destination text. Minimum distance and maximum distance are set to 0 because we wanted the actual match of the words, so to ensure that there's no spelling mistake. So for the match and unmatch part, I used a T filter row. T filter row to actually filter out all those data with values equals to 0, because this means that they are of the correct spelling. So they would then use the same schema as defined earlier during the metadata, and then those with the correct spelling will be output to a CSV file called match underscore my metric number, and then those who are unmatched will be at SQL server under database Sakila with the table name of my metric number and underscore unmatched. Okay, so let's run this job and then we'll see what happens. Okay, so while it is running, as you can see here, other than the job itself, documentations are also very important. So I did my fair share of documentation over here. You can see, so it documented down like what's each component for. Yes, and of course for the job itself, there's also a purpose and a description. Okay, just give some patience while it loads. Okay, there we have. So now let's take a look at the data that we matched. So here, but this is the match one, the CSV file of all the correct data. You can see from here, this is matching with this one, with this column here, and the value is 0, meaning correct match, and they are all of the correct spelling. So for the ones with incorrect spelling, is actually in my SQL database. So let me just show you through the command prompt here. So enter password. Okay, so over here we show database, and we select Sakila, which is the database the table is stored at. Oh, sorry, it's here, Sakila. And then select all from match. And here we have all the data that are with spelling mistake. Just give it a moment while it loads. Okay, so as we can see here, I actually did all the data with wrong spelling, like Suntec City, which is wrong, Suntec, and then Woodlands, which is spelled wrongly. So this comes to the end of my video walkthrough for this. Thank you very much. So good morning lecturers, my name is Christina and now I'll be going through the video walkthrough of my question 3A for the assignment. So for question 3A, supposed to load in this grid logs into the HDFS and then create a table and populate the table with these grid logs. So what I did was I actually uploaded it manually. So before we do anything, let's just check the IP configuration. So the IP address for Sandbox 2.2, which is 192.168.56.103. So using that, we're able to load out here. You can see from here, I've already uploaded the grid logs. It's over here. So what happened now is I will create a table. It's actually documentation written on like what does the query do. Like for this one is the table would drop if it's already exists, and then after which this job will just create the table and with the data types defined. So without further ado, let me run this job first. Okay, so what happened is over here, this job table if exists, there's this query called job table if exists, and tweets is my table name. So just take a look at the schema. It's actually nothing yet because it's just a table. So for the connection, I actually connected it to sandbox with port 10,000 and then all this following the IP address that is defined earlier on in the terminal. Username is HDFS and of course connection mode standalone Hive 2 distribution is Horton works version is platform v2.2. So at this create table here, we created a table called tweets with all these parameters and data types defined. So it's about the tweets and everything that I think is needed. So yeah, so after we are done with this one, we have to go on and populate the tables we created with tweet logs, which let me run this job over here. Okay, so maybe when the result are loading, let me just go through my query. So I selected t dot after midnight as this table name for after midnight, and then tt dot before midnight as this table name for before midnight. So what happened was I count the amount of tweets where the time is like where tweet dot time, which is the time, is like starting from 00 and or 01 or as well as 02, 03, 04, 05 because I defined because after 05 which is 06 it will be morning already, so all this will be after midnight tweets and then joining the table with a a count of before midnight tweets, where tweet time is starting from 1, 2, and 06070809, of course. So join these two tables together and count the number of tweets tweeted at this before midnight and after midnight. So yes. Okay, so you can see from here the table name is already being named as after midnight and before midnight. So the number of tweets before after midnight is 511802 and before midnight is 3899. So yes, this is my query, and yes, I've come to the end of my video walkthrough for this question, uh, for question 3A. So yes, thank you for sitting by. Thank you. Okay, so good morning lecturers, my name is Christina, and today I'll be going through my question 3B, which is for the pig component. So firstly, we would like to check our IP address. Our IP address for pig will be 192.168.56.104 under the sandbox 1.3. Okay, so first, before we start, let's activate this job, and then now I'll run this job to input the formatted tweets into the HDFS output. So as you can see from the configuration here, the name of the URI follows the IP address 192.168.56.104. Host will be 8020. Username is HDFS, and then output will output as the under this location with the name tweets. So field separator is comma. Schema is as followed here. Okay, so we can see here, there's a total of 581800 rows loaded in. So let's just check if it's loaded in here. Refresh. There it is. The tweets is loaded in here. Okay. So before I run, just let me deactivate this one. Secondly, I'll run this over here. So our main objective over here is to obtain the top 5 Twitter user based on the number of tweets they tweeted. So firstly, we'll load in the file that we uploaded just now from the HDFS using this pigload. Schema is still the same. Using the 1.3, load function is pig storage, and the name of URL follow the IP address. So and here is our job tracker host, username HDFS, and then our input file is at this location, formatted tweet, and for field separator as comma. So what we do next is we filter out the day that matches Friday, Saturday, Monday, Tuesday, because all the tweets they have the day with them. So for this one, we can just filter out the tweets, and the next job will be calculating the tweets, the number of tweets grouped by username. Our schema is as follows. We only need we input this total tweets as our new output, and the username is our group by. So what we do is we added in the total tweets as our output column using function count, and input column is username, because the amount of times the username occurs is the amount of time the user tweeted. Next up, using tpig sort, we sort the total tweets in descending order. So why in descending order is because the highest number of tweets will come out first, and then the lower one will at the back. Here's our schema. Okay, so next we store it at under formatted tweet qn3b, separator comma, and at the store function as pig storage. Schema is over here, still same as the previous one. So looks like this job has finished. Just check whether we have this with us. And there it is, qn3b, and here's our tweets and number of tweet and the username. Okay, so let's move on. Okay, so what we want here is, because we want to obtain just the top 5, so we need to use some tools to limit it into 5. So what we use here is a T map. input using the THDFS input to input the file back. Just roughly go through. Schema will be the same as what we defined in tpic store result just now. Name of URL follows IP address 1.3 Hortonworks and field separator, comma, and username as HDFS. So from this location called QN3B. Next, using tmap, we use a query over here to limit it into 5. The reason why we only map username over is because what we needed is to obtain the top 5. So in this case, I feel that total number of tweets is not needed. Lastly, output to THDFS output. IP address follows. Schema is over here, username only. Hortonworks and 1.3, version 1.3. So the file name will be top 5. Username HDFS and yes. So this job is has finished running. Let's just check whether we have it with us. The QN3B and top 5 here, and here it is our top 5 user. So thank you very much. Finish going through my B for the file loading. So for the analyze part for question 3B pick, we have to come up with a job with an analyze of our own. So here let's just I'll run the formatted piece into HDFS again. Okay, so as mentioned above, the IP address will be the same 192.168.56.104, and then the output will be under this file name called tweetspot and analyze, and then the field separator, comma. Schema is as followed here. Okay, so looks like it's completed running. Just go back and check if our file is there. Yes, the tweet for analyze is here. Okay, so next we just have to run our own job. Okay, so the objective here is to actually filter out all the tweets that is tweeted on Monday, and then here it is. So for the load the file from formatted tweet in this location here. Username HDFS, as usual, name node follows IP address, and then I use tpic filter to filter out the day that matches Monday because I only want to find out tweets that's tweeted on Monday. Using remove column, tpic filter columns, I removed away the columns that I deem unimportant. So you can see here, the only columns that I wanted was username, day, month, date, and tweets. Next up, using tpic distinct, I distinct out all this column over here because I only want one tweet per user per day, which is Monday. And then I using tpic sort, I sorted them by username in ascending order. Schema is over here. Okay, so lastly, the result will be stored as question 3B analyze separator, comma, underscore function for pick storage. Okay, looks like it's loading. Okay, so now we can see that the job is finished running already. So we can go and look for our result. So question 3B, let me just refresh this. Yes, 3B under analyze here. So here's our result. Is the result that comes from the job. The username, you can see, starts from A and then to B, C, and then they are tweet. And each username only appears once, and it's all from Monday. Okay, so thank you for listening through. I've ended my go through for question 3B for this part. Thank you.